Okay, so what I want to do today is talk about how we're deciding where we are on the phase change graph. I think that's where a lot of people are getting confused. All right. So, like I told you on Friday, first thing I want you to do is map you out a graph. So, how much heat is needed to raise the temperature of 20 grams of ice at -5 degrees Celsius to water at 65 degrees Celsius? So, if we draw our normal stair step graph, okay, remember here is where ice is, here is where liquid water is, and this is where we are at vapor. Okay, it is at this point that we're melting, and it's at this point that we're vaporizing. Okay, so let's look at where we are. So I'm going to put some points on our graph. It says that we're at, first of all, we know that ice melts at 0. We know that water boils at 100. So what I want you to realize is that we're starting at -5. So we're going to start here at -5. Okay. And we are going to 65. So 65 is between here. So that means that we're stopping somewhere around here, right? Okay. So it says that we've got 20 grams of ice at -5. So we know that we have to do this part. We know that we're going to have to melt in order to get to water, because that's what our ultimate goal is water. And then since we're not going above 100, we're stopping here at 65. All right. So when I look at the equations that I'm going to do, remember, if I'm on a slant, anytime there's a slant, you use Q equals MC delta T. Anytime that there is a horizontal line, you do Q equals either MHF or Q equals MHV. This is always the bottom horizontal line. This is always the top, okay, top, and this is always the bottom. All right, so if we put in these different ones, let's look at what our total heat needed would be. All right, so we're going to start. I'm going to start here with ice. Okay, it says that I've got 20 grams, so my mass is 20. I've got, remember, the specific heat of ice is 2.05, and I've got a temperature change of 5. All right, that's going to be my first calculation. The next thing I've got is the melting. So I've got the 20 grams and my heat of fusion. So this is always the heat of fusion. Heat of fusion is 334 grams or joules per gram. All right. So that's my second one. And then my last one is this portion right here. So 20. And then for the specific heat of water, it's 4.18. And then when you put that temperature change, you're going from 0 and you're stopping here at 65. So there's just a 65-degree temperature change. So when you get all these and calculate this up, okay, let's see, let me do this real quick. 20 times 2.5 times 5. So this is, make sure I'm doing this right, 20 times 2.05 times 5. Right, this is 205. This is 6,680. And this is 5,434. So then I just add all those numbers together, and I get a total of 12,319 joules of energy. Okay. All right, let's look at another one. So how much heat is lost? So when you see the word lost, you know that you're going down, you're cooling. So when you do your phase change graph, you're starting here at the top. Okay, you're cooling. All right, so this is still vapor. This is still water. This is still ice. You got to remember, the bottom slant is always ice. The top slant is always vapor. And then in between, this is why I said the top is always going to be heat of vaporization, and the bottom horizontal is always going to be heat of fusion. So when we're cooling, it says we've got 150 grams of vapor at 100. Well, let's put in the points we know. We know that right here at 0 degrees is when water freezes. We also know that it is at 100 degrees when it is vapor, okay, when it's finally vaporized. So we have 150 grams at 100 degrees, and it's cooling to 0. So that means we are going to start here at 100 because it's vapor. It has not got to water yet. So that's how I know that I've got to use my first equation of Q equals mHV, which is going to be 150 times 2,260. The next thing is that I'm going all the way to ice at 0, so I've got to go through this whole slant. So that's going to be the 150 times the specific heat of water times the temperature change of 100 degrees. And then I'm finally stopping here because notice that it says I'm stopping at ice. So basically, I am at this point on the graph. I'm not going below. There's no temperature change, so I'm just at 150 times my heat of fusion. And when you calculate that all up, give me a second to calculate. So 150 times 2,260. This is going to give me, let me make sure I did this right. 150 times 2,260. 339,000. And then I do 150 times 4.18 times 100. This is going to give me 62,700. And then 150 times 334 gives me 50,100. And now remember, I got to add it all together. So plus 62,700 plus 339,000. This is going to give me a total heat loss of 451,800. Now remember, this is negative, okay? Because I am losing that energy to the system and it's warming up the system. All right, so that's what you're doing. So remember that keywords, when we're looking at this, keywords are, if it says vapor and you don't see anything above 100, you know you're at this point on the graph. If it says ice and it's at 0, you're here on the graph. Okay? Anytime you see a water, like we looked here in this one, it stops at 65. Remember, water is no longer water once it gets to 100. It's now going to become vapor. So that means I'm in between. I'm on this slant somewhere. So that's how you determine where to start and stop your graph. So I hope this has cleared up any confusion that you've had with these problems. If you're still having trouble, send me a message on Remind, and I'll try and help you out, okay?